Let's talk about transformations today. Hi, and welcome to Algebra Examples. I'm Dr. Finch. Today we're going to look at an example where we're describing how the graph of a function is a transformation of the original function f. And there's a lot of stuff to keep track of with transformations. I hope whatever teacher you have, they give you a little bit of a note card or something because there is a lot of information and it's not worth the brain space to memorize all of it for some of these. All right, let's dig into this and we're just going to talk through all the things that happen on these together. We'll start off with our first function, 5 times f of x plus 3. Okay, so there are two things that are going on in this particular graph right here. We have the 5 times our f of x, and then we have the plus 3 on the outside. When we have a plus 3 on the outside, this is a vertical shift. And it's going to go up or down depending on whether it's positive or negative. In this case, we're talking about a positive 3. So our graph is going to shift up plus 3 units because we have a plus 3 on the end. So that is one of the things that is going to happen in this particular transformation that we're looking at. All right, now let's look at that 5 on the outside of our function f of x. When we have something of an a times an f of x, where a is a number, this is going to be a vertical stretch or compression. And there are three things that could possibly happen when we're talking about this. The first thing, if a is bigger than 1, then we have a vertical stretch. And if you think about it graphically, if we have something like, if our function looks like this, our vertical stretch will kind of pull it like putty so it goes up higher. So that's going to be our vertical stretch. And that's, we can think of this as 5f, and then our little one is f itself. So that's what we're looking at in this case. If our a value is between 0 and 1, then we're looking at a vertical compression. And that's going to be slightly different in the fact that if we have, I'm going to put, if we have our f of x, let's say that's our f, our compression would move it closer to the x-axis. So for instance, this one down here might be 1/2 of f instead. Now I said there were three things that might happen. The last thing might happen is that a is smaller than 0. And when that happens, it's going to be a vertical stretch or compression. And on top of that, it's going to be a vertical reflection. Whew, that's a lot. So in this case, we're looking at our first option. Our a is bigger than 1. So we also have a vertical stretch of 5 units. And we're not asked to draw it, thank goodness. So we just have to say it's going to shift up and then it's going to be stretched. Okay, let's look at part B. I'll put a line here. Let's see. Our B was y is equal to f of 1/2 x. So you'll notice in this point, it's slightly different because all of a sudden we don't have plus or minus anything on the outside, which is nice. But instead of that having a number on the outside, we've got a number on the inside of our function. So when that happens, we are looking at a horizontal stretch or compression. So we might look at f of b times x, where b is some number. And this is going to be very similar to what we saw before. There are three options. We have b is bigger than 1, then we are compressed. By b. If b is between 1 and 0, then we are stretched. By 1 over b. And if b is less than 0, then horizontal stretch or compression. Plus a vertical or plus a horizontal reflection. When we talk about things being compressed on the horizontal part, we're going to have a slightly different one. I'm just going to put one example for us. We are going from, let's see, we are going from f to 1/2. So if we had, say, our original function looked something like this, f of x, let's say it looked somewhat like a quadratic, then f of 1/2 x would be looking like that. So we have it, it's stretched out a little bit more, and we see it has a little bit more give to it. Compression would give it closer to the y-axis. So in this case, our function is stretched by 1 over 1/2, or stretched by 2 is another way of saying that. So to put this all up, there's a lot going on in this sort of a problem. And again, I really hope that whatever teacher you have allows you some sort of notes, because this is a lot to keep in your head, and you probably won't be using it after you get done with your algebra class. But it is good to know for now. Thank you for listening.